everyone. Got it. This will also be a recorded workshop. So if any one of you guys sort of missed anything in the workshop and want to go back to it, it will be on our YouTube channel. And if you want to share it to your friends, if they missed it, they could also watch that as well. So just a little bit about us is that we're a chapter at Ryerson that is trying to include and be inclusive to all the students that are interested in transportation and are in the transportation profession. We try to get the students closer to professionals in the industry and try to transfer knowledge that way and just help students improve their soft skills by, as such as this, doing a workshop to help you improve your soft skills. We also have networking events like we did previously, and we're just trying to engage the community at Ryerson with transportation. The itinerary for today will be introducing our instructor, Saba Sabet. After, we're going to have our first session, which is just the basics of data analysis with Python and the relevant libraries that Saba will be teaching. Next, we'll have a Q&A session. So that is going to be anything that Saba has taught during the session. You guys can ask either on the chat room, or you could unmute and talk. Either or is fine, whatever you guys are comfortable with. Then the next is going to be a little break for intermission. And then the second session is just going to be teaching the basics of data visualization with matplotlib, and also a task for you guys to do regarding matplotlib. And then at the end and during, while you're doing the tasks, there will be Q&A if you guys have any questions, and the conclusion. So without further ado, the introduction to Saba. Saba is a PhD candidate in the Transportation Engineering program at Ryerson University in Toronto. She received her Bachelor's of Science in Amir Akbar University of Technology. She also has her Master's of Science in Transportation and Highway Engineering from Sharif University of Technology. And she is, oh, I already explained the PhD candidate. But yeah, that is Saba. She's very well experienced and very well traded. So she'll be a great instructor for you guys. Without further ado, if Saba, you want to start the first part.
Hi, MD.
Hi.
Thanks for the introduction. And hello, everyone. I'm Saba, and let me see if I can. I hope so. Are you? Yeah. So, have a great afternoon. It's Saturday afternoon, and thanks for giving your time to us. I'm going to share my screen. So I think in this regard, I would like to stop the video and just put my screen on. I think you all have access to the files shared in here, Python course. I hope everyone has access to that. If not, you can just write your emails, and yeah, if you don't have access to that, you can write your emails here, and me or Niall would help you get access. So what we're going to do is to talk about Python first, and then we don't need a history of Python and other languages. Everyone knows history. But what I'm going to do is to help you first install Python, because I think a number of you, might not even have installed Python. And if all of you have installed Python, we can start from another step. But is there anyone who doesn't have Python yet? Do you need help with the installation of Python? So I would say that means everyone has Python. So let's get started with session 1. Open my slides, yeah. And change the shared drive. So Python for data analysis. Our first part is about Python with data analysis. We will overview the Python and its libraries for data scientists. We would talk about reading data and selecting and filtering the data manipulation, sorting, grouping, rearranging, and then plotting the data and talking about descriptive statistics and inferential statistics in this part. So what is Python? It's a general purpose interpreted programming language. Also is a language that supports multiple approaches to software design, principally structured and object-oriented programming. If you don't know what is object-oriented programming, just wait till the end of the session. You would be familiar with all of these terms. Provides automatic memory management and garbage collection. And it's also dynamically typed. And by the end of this tutorial, you will understand all of these terms. So to talk about some history, over 6 years ago, in December 1989, I was looking for a hobby programming project, and then he said that he was occupied during the week around the Christmas. So he chose the name Python as a work project title, and then become slightly irrelevant mood. He was a big fan of Monty Python's Flying Circus. So he named his programming language Python, and he managed to invent Python for the first time. The goals of inventing Python was an easy and intuitive language, just as powerful as major competitors like C++ and other things, and an open source so everyone can contribute to its development, a code that is as understandable as plain English. I think Python is very simple, whatever you want to do, you just write it down. And then suitable for everyday tasks, allowing for short development times. And yeah, it's a very comprehensive language. So when we want to compare these types of languages, like interpreted languages like Python, and compiled languages like C++ and Fortran, we would see that these types of programming codes and languages are much faster, and you can develop it much faster. Then it's easy to debug them. Debugging can stop anywhere, swap in the new codes, and you have more control over the state of the program. Then, almost always it takes less code to get things done. For example, when you're doing a simple task with Python, it maybe takes 1 or 2 lines to do the same task than doing it in, for example, in another language like C++. So then, I was missing that. Yeah. Then, it has slower programs. Sometimes they are not as fast as they are compiled, because they are rarely faster than C++ compilers. Then you have less control over the program behavior. But in C++ and other compiled programming languages, you have more control over the programming behavior because, they are faster, they can compile more optimizedly, but they are harder to debug and they need longer development. So you can just try Python as a calculator first. For example, when you use Python and you input 1 plus 3, the output would be 4. So it's just like a calculator. You don't need to write several lines of programming, for example, and do that to get this result. Then when you write, for example, 4 multiplies 2, you will get 8. And that's it. So go to Python prompts, try out some arithmetic operators if you haven't done yet, and you can identify what they all can do. In Python, we have different types of data. First, we have numbers. We have integers and floating points. For example, we have 64 bits like other languages. Then also we have complex numbers. For example, the x equals to complex 3 and 1 means x equals to 3 plus 1j. We have strings like C++ or other languages using double or single quotes here like cat or dog. We have Boolean like true and false or 0 and 1 variables. Then we have lists, dictionaries, sets, and tuples. So this whole collection of variables are possible in Python, and we have different types of data like files, network connections, objects, and the custom types can be defined using Python classes. So for example, I will talk about the classes more in the future, but we can have, for example, different classes for different dogs, or different classes for different animals, for example, or for a couple of people. We can have different classes like teachers, nurses, stuff like that. So about modifying operators, some additional arithmetic operators that modify variables like here, when you put x plus equals to y means that you want to add the value of y to x. So these are the equivalents of what you type here. And as you know, in other languages, when you write this, so the other part of the equivalent like x plus y would be added to x. And then we have this for subtract, multiply, and divide. And also we know that the plus equals operator is by far the most used ones among all of these things mentioned. So we have some functions in Python. For example, you want to do a summation of some numbers. Then you want to, for example, get the average of some numbers. These are the functions. So first we use the keyword def, means we are defining the function. Then we write function name, for example, def, I don't know, avg, for example, like average, I don't know. Then argument 1 and argument 2 are optional comment separated lists of arguments. We don't know how many, for example, variables are here. And then we write some code. This is a code block. Then we return some value. This return means this gives you, for example, the average of the numbers, the summation of the numbers. This is an optional return statement. So the return value can be any Python type, for example. If the return statement is omitted, a special non-value is still returned. So it returns something, but if you don't write the return, the value would be none. So it continues. Then the arguments are optional, but the parentheses are required. And functions must be defined before they can be called. So first you should define some function, and then you can call it, for example, in another part of your code. If and else. If or elif or else, for example. When we write if means if something is true, you would do this one, for example. If Boolean value, some code. Or for example, if the dog is red, it would, I don't know, for example, call it something, call it yellow, for example. Or else if. Else if means another argument, for example. Else if, I don't know, for example, the cat is white, then call it black, for example, something like that. But else means the other arguments are done, and it's only one option here. For example, else means any other options, you would do this. So that's the difference between elif or else. This is else if, like we had in C++ and other languages. So this is the syntax. And elif are not required, maybe here. You don't have Python, and I will help you install Python in order that you can run the codes we need here. So while loops. We have some loops in Python like any other languages. We have for loops, we have while loops. While loops have a condition and a code block. The indentation indicates that what is inside the loop, what is inside the while loop, and it will run until the condition is false. For example, I can say while the animal is dog, it will bark, for example. So while it is true, while you see a dog, it will bark. It would go to the false option when it sees, for example, a cat, another type of animal. So the break keyword will stop while a loop is running. You can write, for example, break. Break means if something happens, you just stop the code. In the spider is a kind of notebook for Python. You can edit enter in some loops like this, and you can save and run them one at a time, and then you see what happens with the first loop. So just even if you don't have spider, you can run this code. So just write this code in your compiler. Anything, I don't know, you have any ID? Do you have any ID, for example, PyCharm, Jupyter, anything? If you have, Please write this code and tell me what would be the result. Just the first one, while true, print looping. You don't need the rest of this. Just write these 2 lines and tell me what happens.
Saba, sorry
Yeah.
to stop then. Could you please show them how to install Python first? I believe most of them don't have Python already.
Yeah, sure. So if you want to install Python, first you should choose what kind of IDE is suitable for you. I work with PyCharm, or some people maybe work with Visual Basics, for example, Visual Basic Studio, anything like that. Just choose your IDE, and then, for example, you can go to here, PyCharm download. So this is here. You don't need the professional one, you just need the community one, the free one. I already have PyCharm, so I don't need this one. But because it is free trial, I think this one is better because you always have access to this. So just download it via this community, and the installment is very easy. I can share you this link in the chat. You can have any other IDE, but this is fun. So if you already have Python, just write these 2 lines and tell me what would be the result. Yeah, exactly. This is going on, printing looping, because we don't have any kind of break here. So we don't say, so when would you stop? We don't know. And while true, it is always true because you didn't tell them what is false. When would they have to break the code? So if you just write these 2, it will keep writing looping for you. And you would be in a kind of never-ending loop. So for loops are a little different. They loop through a collection of things, for example. And the syntax is like here. In the loop, you write first, we write for, and in the loop reference variable for each collection element is here. For x is in this range, for example. This is the range, this is the collection. Range 1, 2, 3, you would print x, for example. This is the code block. What would they do, for example? While it is true, what would they do? For it is in this range, what would they do? They would print x, for example. The for loop syntax is a collection and a code block. The collection has a range, and each element in the collection is accessed in order by a reference variable. And each element can be used in the code block. For example, you can say, for example, print number 1, print 2. The break keyword can be used in for loops too. So when do they break this? But even if you don't have a break word, it would stop because we have a range for x, 1, 2, and 3. The range function auto-generates sequences of numbers that can be used in the indexing of your list. And the syntax is like range. Start range, it would start by 1, for example, and we would end by 4. And the increment is, for example, 2. So the increments, if I write start by 1, for example, and the exclusive end is 4 and increment is 2, it would start by 1, 3, and that's it. It won't go to 4. So the increment is very important. If you want it to be, for example, if I write 1 and 4, it would start by 2 because the number I write here is not included. So if I want 1 to be included, I should write start from 0. And then, like here, range from 0 to 4 produces the sequence of numbers 0, 1, 2, 3. It won't add 4 here. If I want 4, I should write 5 here. Range -3, 15, with the increment of 3. So it starts by -3, 0, 3, 6, 9, 12, but it won't add 15. If I want 15, I should write 16 here. And this is another range. So try this, print range 4, for example. Try this one with your code and tell me what would be the results when you print range 4. Here, the range would be here. X is in this range, print X. If you just write 4, means the increment is 4. So it would start by 0, for example, 4 to 8, and it would never end. We have also modules. Python modules, also known as libraries or packages, add functionality to the core of Python language. The Python standard library provides a very wide assortment of functions and data structures. Check out their brief tour for a quick intro. You can just check out that one if you have access to the slide. Distributions like Anaconda provides dozens or hundreds more. So if your IDE is Anaconda, you would have dozens or hundreds of more libraries, but the PyCharm wouldn't install them for you. So you need to install them yourself. I would help you install the library and understand how they are installed. You can write your own libraries or install one. Python libraries required for data science. Actually, there are so many libraries, and there are no limits for the libraries. For example, each day one might introduce a better one, and you might need to use another one, for example, for different functions. But many popular libraries and toolboxes are based on these mentioned ones: NumPy, SciPy, Pandas, scikit-learn, and for the visualization libraries, we have Matplotlib and Seaborn, and many more. So let's know how to install libraries. First, you can see these. All of these are installed based on NumPy. Then these are installed based on these. And each type of these libraries you can see needs a basis of NumPy, or for example, Pandas, or any other ones, Matplotlib, SciPy, or stuff like that. So NumPy introduces objects for multi-dimensional arrays and matrices, as well as functions that allow us to easily perform advanced mathematical and statistical operations on those objects. Also, it provides vectorization of mathematical operations on arrays and matrices, which significantly improves the performance of our coding. And many other Python libraries are built on NumPy, as you can see here. And more about NumPy is in this link. And we have SciPy, a collection of algorithms for linear algebra and differential equation, numerical integration, optimization, statistics, and more and more. And a part of SciPy stack also built on NumPy, like other libraries. And you can find more about that in this link. Then we have Pandas. Pandas adds data structures and tools designed to work with table-like data, tabulars, similar to series and data frames in R. Provides tools for data manipulations, reshaping data, merging data, sorting them, slicing, aggregation of them, and etc. Also allows handling missing data, which is called censored data. Another library is scikit-learn. It provides machine learning algorithms like classification, regression, clustering, and model validation, etc. It is also built on NumPy, SciPy, and Matplotlib. So when I say this is built on these, means that in order to have scikit-learn like this, you need that your NumPy and SciPy and Matplotlib libraries to be installed before. And Matplotlib is good for visualization. It's a Python 2D plotting library which produces publications quality figures in a variety of hard copy formats. A set of functionalities similar to those of MATLAB and line plots, scatter plots, bar charts, histograms, pie charts, etc. Relatively low level. Some efforts needed to create advanced visualization with Matplotlib. These are some images produced by Matplotlib. You can see they are not advanced actually. I think they are enough for most of our engineering daily tasks. But if you need to do more, you can refer to Seaborn. Seaborn is based on Matplotlib, means if you don't have Matplotlib, you can't install Seaborn. It provides high-level interface for drawing attractive statistical graphics, and it is similar in style to the popular ggplot library in R. So first, for example, when you're writing a code, you need to import your libraries. For example, import NumPy as NP, import SciPy as SP. If you don't import your libraries, they won't be called in your code. So you need to import them here, but before importing them, you need to know how to install your libraries. First, Thank you, Talha. So first, if you want to install a library, you can go to your command prompt here. For example, make sure that your Python is installed. And when you go to this command prompt, you just write, for example, you need to be friendly with pip. Pip has a variety of options for you. This is the options that pip can provide. Pip has install, download, uninstall, freeze, anything, for example. So it can download the package for you, it can install the package for you, it can uninstall, it can freeze, it can check, show, debug, complete, anything. If I want to install a library, for example, I should write pip install, I don't know, for example, pandas. It is already installed for me, for example. And then that's because, you know, for example, pandas is already here. I don't need to reinstall it. But even if, for example, if it's a new one, pip install, I don't know. For example, matplotlib, I think I have. Yeah, also I have matplotlib. So if it is not installed, it will install this for you. Requirement already satisfied. See here? Means I already have matplotlib. If you're using Anaconda or Conda packages, you already have several of these libraries. I don't know. Let me choose another library that I may not have. AstroPy, maybe. I don't know. Number. So this is installing that library for me. And this is installed, successfully installed, for example. Actually, what happened is that it uninstalled NumPy and then installed Numba for me. Because when you're installing some of these libraries, they might uninstall the other libraries which do the same thing and which are, for example, not that much progress or advanced. So I want to uninstall Numba. Or, for example, pip install NumPy. Requirement already satisfied. NumPy is already here. So what I want you to install is matplotlib, pandas, and NumPy at this stage. Just install these three, and then you can add any other things you need. I give you some time to install them via this pip install thing. I have pip. First, I don't know if my screen is shared with you. If you run into the same problem, you may not have pip. So you have to write download pip, and then you will go to this, for example. And then, let me see. Here, this can install pip for you. This part. If pip is not already installed, you need to make sure that pip is available. For example, if this is not installed, you should write download from here. Let me copy that for you and write it here. From this, you can get pip. And then run Python get pip.py. This will install or upgrade your pip. Any other problem? Did you make it, Talha? So let's just continue till you can download your pip. I will continue with this part. So reading data using pandas. First, for example, you need a set of data. You have a CSV or maybe, for example, an Excel file, anything like that. First, you have to write read CSV file, for example. This is what I write for myself, for example, so that when someone else is reading my code would understand what am I doing here. For example, the code would not run this part, but this is my explanation for this part of the code. So df, for example, pd read CSV. And this is where, for example, the CSV is here, for example. The above command has many optional arguments to fine-tune the data import process. There is a number of pandas command to read other data formats, for example, read Excel, or maybe, for example, not NA values, read Stata, for example, SAS or HDF, for example. Then data frames with pandas. We have objects, for example, which is that string I told you. We have int64, which is the integer I told you. We have float64, which is the float number. For example, 12 is an integer, but 12.1 is a float. Then we have, for example, dates times 64, time delta, like we had what in our, for example, Python, native Python, we had NA, like not a number. And then the data frames attributes in Python are like here, df attributes, means D types, for example. It can list the type of the columns. For example, we have columns, the column names, we have access, for example. These are the row labels and column names. We have theme, like dimensional, for example, the things, or we have size, we have shape, we have value of the, for example, columns or the data we are importing. Then we have head and tail, means the first and the last row, for example. We have describe, means the general descriptive analysis, or for example, descriptive statistics of our data, like numerical columns only actually. Then we can use maximum, minimum, mean, median, for example. For example, the median of 1 to 10 is 5, for example. And the mean is the same here, but the median of 1, 3, and 5 is, for example, I don't know, anything, 1, 2, and 5. The median is 2.5, but the mean is not the same. So the median is the mid value of this list, but the mean is not the same. Mean is the average. So STD, standard deviation. Then we have sample, like return a random sample of the data frames, for example. Then we have drop NA, means drop all the missing values of these columns, for example, of data. Then we have other types of missing values, for example. We can decide what to do with the missing value. Return true, for example, I don't know, delete them, anything you want to do with the missing value. This is what pandas is always helpful for, to deal with the missing values. You can use any of these comments. So the aggregation function in pandas, for example, you can compute sum, I don't know, you can count, you can compute, for example, mode, standard deviation, variance, anything. Like here, for example, we have a kind of data, then we need departure delay or, for example, arrival delay of a data related to a kind of airport maybe. Then we use, for example, aggregate minimum, mean, and maximum of these columns and rows of our data, for example, about one airport. So it just writes departure delay and arrival delay, minimum and mean and maximum here like this. So this is how Panda is useful. Then let's go to Matplotlib. Matplotlib, as I told you, shows the different types of graphical, for example, analysis. And we have box plots, we have, for example, any bar plots, any kind of plots, for example, with the data. And we can do some statistical analysis using stats model and scikit-learn. We can do an ANOVA test, linear regression, hypothesis testing, And with the scikit-learn, we can use k-means, for example, support vector machines, random forest, and many more. To learn more, you can use the examples in the tutorial notebook of each of these libraries, for example. So you can just search scikit-learn tutorial and you can see what it does for you. So if you have any problem with Python, for example, you're writing a code and you have a problem, where you should ask your question. You can first try to find your answer in the official Python tutorial. Then also you can go to the automate the boring stuff with Python website. Then Python full speed Python tutorial. Then you can go to GitHub or Stack Overflow and see your question. About Python, I can say whatever is your question now, it has been someone's question before. I can really guarantee that for you. So the conclusion is that thanks for being here till now, and then let's do some kind of exercise for this part, and we will then get back to the second part of our workshop. So what I wanted to talk about data analysis, and I may have lost. I'm just making sure that I have done all of this. So this is a data set to import to your Python. Just make sure that this data set is in a folder that you're using now here. And then let's do a kind of exercise. So this is a code you have here as the looping list. Put these two in the same folder, and then run the code here. And tell me what is the results. Also put this one in the same folder and run this code as well and tell me the results. You must have Matplotlib and NumPy for these two exercises. And by the time you're doing that, you can ask me any question you have regarding the first parts. Then we can go to the Matplotlib data visualization part. So can you share your screen? I can give you access to that. You can show what was the results. Yeah. Let me give access to you to share your screen. Yeah. So can you also open the code and tell me which part of the code is this one? Like debugging it and seeing what is happening in the code. So as I told you, first you read the file, you write the file name, for example, anything. The file name is waves.txt. Then in the second step, you plot it in. And in the other step, for example, we need some time step for this one. So you add a time step to this one, and then it would display the whole kind of plot with the time step you wrote and with the data you added. So thank you. And let's go to the Matplotlib to see more. Let me open the other one. So, using Python to retrieve and visualize data. What we're going to talk about is that Matplotlib can help us visualize our data. Why are we doing this? Because a picture is worth 1,000 words. Data visualization is very important because you have to show the analysis of your work to someone, for example, who might not know anything about what you have done. And through data analysis, you can show the data visualization. You can tell them, for example, what you have done in some pictures instead of words. So it helps you see the data in certain meaningful patterns, and it helps visual representations that can enhance the human cognitive process of any type of data analysis. So our learning objective is to create reproducible data visualization and to write and execute computer codes to automate difficult and repetitive data-related tasks, and to manipulate the data and transform it across files and systems, and flat files, for example, databases, programming languages, etc. So before we go to the talking about each part of this Matplotlib tutorial, you can have kind of 5 minutes rest, and then we can start back from the second part of our workshop talking about Matplotlib. If you have any questions from the first part, you can ask me your questions. So let's get started with the second part. Matplotlib can help you bring about reproducible results. A script is a record of entire modeling and data analysis process. So by simply running the script, you reprocess the entire model or analysis. How about that for reproducible results? That's why what's brought them to invent some kind of library that can help them visualize the data analysis they had performed. In order to maximize reproducibility, everything can be recreated, so that other programs can read that as well and other people can understand what is happening here. So this is a graph plotting library of Python. Using these plots, you can visualize your data, and then it can provide an object-oriented API for embedding plots into one application using general purposes GUI toolkits. Also using Matplotlib, you can plot different scatter plots, for example, line graphs, bar graphs, and different types of charts that you may, for example, need for your work. And histograms is also available here. So how to create a time series plot using Python? We will use the following Python packages, for example, Matplotlib, and run the following command for install this, pip install Matplotlib. So type pip install Matplotlib in the Jupyter notebook or anything. If you don't have it yet, this should work in most cases. First, we should know the anatomy of a figure. So we have some major ticks, for example, minor ticks like here. We have y-axis label. This is a figure. The whole thing is a figure. This is the legend. These are the grids. These are the lines or line plots. And these are the markers or scatter plots. These are the spines. These are the x-axis label, for example, and minor tick labels. So this is the whole anatomy of a figure. First, you should know that just as we use the NumPy or NP shorthand for NumPy and the PD shorthand for pandas, we will also have shorthand for Matplotlib, for example, imports. So import Matplotlib as MPL, import Matplotlib or .pyplot as PLT. The PLT interface is what we will use for the most often, as we shall see throughout this chapter. Also, we will use this plt.style to choose the appropriate aesthetic styles for our figures. Here we will set, for example, the classic style, which ensures that the plots are creating in the classic matplotlib style. So for the style, I choose classic. Throughout this section, we may change that and adjust it in the way we need. Saving figures to files. One nice feature of matplotlib is the ability to save figures in a wide variety of formats, for example. So fig.savefig, my figure, for example, .png is one format you can save your plots. To import your plots, for example, import your libraries and datasets to plots, you just need to write pd.read, for example, CSV. Then plt.plot for plotting line charts similarly in places of plot other functions that are used for plotting. All plotting functions require data, and it is provided in the function throughout parameters. Then plot.xlabel or plot.y label is for labeling your y and x axis, like here, we can see the labels. Y-axis label and x-axis label and y-axis label. Then we have plt legend for signifying the observation of variables, plt.xticks, plt.yticks for labeling x and y-axis, observation tick points respectively, plt.title for setting the title of the plot, for example, plt.show for displaying the plot. Sometimes we need to remove the axis. So you can customize or remove your axis entirely. Here is how you can get access to each type of your axis and hide it. plt.axis, visible false. So you may just hide it like this is set visible false or set visible true. Setting a custom figure size, plt.figure DPI. Sometimes if you don't know your system resolution, you can just submit this argument of DPI and adjust the figure size argument accordingly. So this is how you show how it shows, for example, the quality of your figures. Maybe in some kind of journals, you need a certain type of DPI, so you can just adjust this. Or plotting two sets of data, plt.scatters twice. You can plot the same sequence of, for example, data twice. Sharing a y or x axis. First, you import your matplotlib.pyplot as plt. Then you have x values, and then we have list, for example, list ranging this one, for example. Then we also have squares, for example, x to the power of 2 for x in, for example, x values, cubes, x to the power of 3, and fig, or for example, I know what happens. Or for example, here, when you write figure share x, means that the x-axis is shared in both of them. So the x-axis is shared, and the y-axis, you can see both the squares and the cubes. Then for the array of zeros, for example, we can scatter x values square and scatter title with square, and x values and cubes with titling the cubes, for example. To share y-axis, you just need to write share y true here. And then filling the space between the data sets. To fill the space between, you just need, for example, you just need to write fill underline between method to fill the space between the two data sets. It takes a series of x values and 2 series of y values. It also takes, a face color to use the data to fill this, for example, and plt fill between. You just need to write this to change, for example, the between color of this, generating the current data. The date time now, for example, function returns a datetime object representing the current date and time. So if you just write, for example, today, it writes today's date and time in today, month, day, and year. And then it prints the date string. Or if you want to generate a specific date, for example, you could just write, for example, 2017 1/1, or the year 2016 month, or the day, for example, is 22. So before we move forward, let's just change the color, the style, or for example, anything about the axis and y-axis of the figure you just drew, for example, about the waves. So using these things that I told you, please just change the axis and the color of the axis and the labels and legends of the wave data text that you run before. So change the color, the access on anything, labels and sizes, and then tell what's happened. You can just have 5 minutes to do that and tell me the results. One of you can share the results with us. Stop sharing my screen and give you access to share your results if you have manipulated the plots. So you can do anything with the plots. You can change the size, you can change the labels, access anything. And we are going to the object-oriented programming now. We can define several classifications. For example, one classification is to define the classes of animals. For example, I'm talking about dogs. So the class I am defining for Python is dog here. The attributes of a dog is to, for example, its name, maybe its breed, its weight, for example, anything, etc. And then also, so it sounds familiar, yeah. So here is what is different from data modeling. We have some methods. The method for a dog is to bark, to run, for example, and the attributes are the properties, and the methods are their actions here. So if we want to create a new instance of dog classes, we just need to write, for example, this underline dog. This is what I wrote as a function or as the class of dogs. So the class of dog is the beagle, the name is Rex, and the weight is, for example, 20 pounds. Then you can get the dog's name, print this dog's name, for example, and it will print Rex for you. You can also make the dog bark and print this, for example, dog bark rough, for example. This is the sound of dog bark. So why rough and why not woof for this dog is how you define your classes. So you define your classes based on your breed, based on the name, and based on the weight. So the property of this breed is to set as, for example, this for a beagle. And then the resources you can go for example, understanding object-oriented programming with Python is here, MIT's Python courses, Google's Python courses, and for example, many other books, websites, courses, etc., which are both online and offline. And for the visualization, I can encourage you to look through the Matplotlib documentation, especially the galleries of examples, plots with this type of code. And this is how you can just get access visualization with Matplotlib, Python Data Science Handbook, and this is ariely.com. So, and yeah, you can go to that. So, by saying that, let's see some kind of samples of what Matplotlib can do. The cheat sheet of Matplotlib is also here for you in session 2 matplotlib.pdf. And yeah, I want to open that. So first, you need to import your NumPy and import your pandas and also your Matplotlib. Please do this 4 lines and import them here for yourself so that you can continue with the rest of our session. Please take your time to import these libraries, and then we can start graphing and changing the style of our graphs and drawing line graphs, bar charts, anything. So I hope you have imported all of the libraries in your code. Then you can change the plot style, but I use Seaboard, for example, Seaborn Dark Grid. You can use the classic style, anything that suits you. So line graphs. By default, plot function will draw a line graph for you. So if you don't tell them what kind of plot are you using, it will by default choose the line graph for you. And the X is, for example, NP arrays. NP is coming from the NumPy you imported here. Arrays, and here the MP power, for example, X and 3. And then the LP plots X and Y here in this plot. So if you write this, you will get this. Let's go to the other one. So if you want to, for example, draw a sign graph here, you will write np.line space, for example, 0, 10, 1000. And then you need a sign, for example, graph here. So it starts from 1, then 10 and 1000. I just cut the diagram for you, so that, you can see that easier, for example. And then it shows the sign graph here. Then we can use different types of graphs. For example, you can show it in a bigger scale, anything. You can change the style, you can change anything here. Change the grids, maybe, for example, this is a darker grid, you can see. And here, for example, if you write PLT plot X, Y, and R, the plot would be turning into red. So we have different type of colors. And also, if you write, for example, RO, it has red spots. And then if you go to, for example, R hats, and it gives you several triangles with red color. So for your own information, please turn to this one. And if you write RV, yeah, the triangles would be reversed. Then the other one here is x2 and x3 to the power of 2 and to the power of 3. And then here you can see x to the power of 2 is kind of having a lower slope than x to the power of 3. Actually, it's vice versa. Yeah. So if you need to define to have multiple sets of data, for example, if you need to plot multiple sets of data, you can use this code. And you can change, for example, the location of your legends. This is the location I chose, the upper right. The legend will be placed at the upper right position. And then you can change the font size here. You can change the color, for example, of your data. You can change the figure size. You can change the line space. This is the line space I chose. Then here, this is a font size, for example, is the large one. So the font would be larger. Setting up a legend, setting up different types of legends here. For example, we have y-axis, we have x-axis, and we have this. This is the equation we need. Then this is this is multiple drawing of sign. And here you need to fill between the functions, for example. So the legend will be placed at here, like always. And if you need to fill between, as I told you, you can just write this fill between, for example, x0 and p sine and x0 and p cosine. So this would fill between the whole graph with different colors. Then you can change the positions and fonts again. You can change the line width here. So your line width is 4 and the other line width is 3. This line would be thicker than the other one. Then you can change the grids, for example. You can change the color of the grids, the line style, anything, the background color, for example. And 2 rows, maybe 1 column, anything here. So this is having subplots. Means, for example, you have one plot, but your plot has A, B, C, D, for example. To the other one, you have 9 subplots in one plot. And then here you can have a kind of bar chart. Maybe these are different types of bar charts. So you can set up the background color by specifying the HEX code here. So the face color is this. If you don't know what kind of face color you need to use, for example, or you don't know these types, you can just, for example, search face colors in Matplotlib, and it gives you a variety of options to choose your colors about. And these are different types of data in one. And yeah, and this is horizontal bar charts. So you can change the width of your bars and anything about that. And also this is displaying the values of the top vertical bars. So if I want the values to be here on top of my bars, I just need them to write, for example, PLT bar. Number one multiplies 2. It's not multiplying, actually, it's to the power of 2. And this is to the power of 3, for example, maybe, if you need. And this is what you wrote, for example, PLT text x and y plus 0.0. And then here we have specifying the edge color by the name. So you can just write, for example, the center, bottom, anything. So as a type of exercise for you, I need you to write a kind of scatter plot here. This scatter plot, for example. PLT figure, for example, you can change the scatter plot here. And also you can have different type of scatter plots with different widths, for example, or different size of the points, different colors, different names, different alphas, and different labels. And this is the pie chart. So you can just use this file as your reference for the Matplotlib, because this is the best cheat sheet I've ever seen about Matplotlib, and this would definitely help you with your future work, maybe for example with plotting something in your papers, publications, anything. And these are even plots that are, for example, they're kind of area plots that are not considered as any of the other types of plots. So you can just put a customized plot here and change anything about it. So, and this is the end of this tutorial for Matplotlib. So as the other part of the session, I need you to go back to the shared file and go back to pandas, download this file, and choose one of these codes from the scratch. Write the import, for example, first import them in your code, and then choose one of these codes. For example, don't choose as really, for example, easy one, choose another one which can give you different types of understanding of how pandas works. And when you chose the code and write the code from scratch to the end from these sets of pandas, 10 minutes to pandas, object orientation, programming with pandas, just give me the results. Tell me what it would be the results. So start from here. This helps you how you should write, for example, 1, 2, 3. So you should choose 4 and 5 here, for example, and any of these types. So choose one of these programs and write the code from scratch, from import, and run the program and tell me what would be the result. You can share the results with us. And by the time you're doing that, you can ask me any question you have.
Hi guys, MD here. So I believe this wraps up about our first workshop for Python. If you guys have any questions, please refer back to the resources that Saba has given. And I feel like these resources can help you get a great start on Python. I wanted to mention that we will have a more advanced workshop on machine learning in January, so please feel free to attend that. Look for our social media posts on LinkedIn and Instagram to look forward to that. And with that, I would like to conclude. So we'll be ending the meeting now, but thank you again for joining us, and I hope everyone learned something today.